1 up through 714. Okay, so on Friday, 711 through 714. If you weren't here on Friday for any reason, that's when we got 713. This Friday, TBD, to be determined, in case you don't know what TBD means, but probably, assuming Miss Glass is able to come, probably our circles activity with Miss Glass. She's got a fun thing planned. It kind of is like a scavenger hunt. So that's probably our plan for Friday, working backwards up the week. Thursday, I'm out. I got to take my wife and her family to the airport. They're going down to visit their niece, who is graduating high school this year. Super exciting, but this is her final performance because she's in theater, right? She's involved in drama. So they're doing, I think it's Little Mermaid, or maybe Little Mermaid was the one they just did. But either way, so she has a performance this weekend. They're going down to see that. So I'm out on Thursday. So you'll take the mastery from Chapter 6 on Thursday. Mrs. Cullinan is your guest teacher. You guys know her. She's subbed for like almost all of us. Wednesday, Jenga. Doesn't really need any explanation. Tomorrow, the other paper that you should have grabbed back there. So you should have 714 and 715 as of right now. Questions? Liam. Because I know the question you're about to ask.
That wasn't my question.
Oh, sure it wasn't.
But do we only do 7 through 9? And yes, can I read?
I think I should read today.
No.
Maybe we. Who wants to be Linda and who wants to be Lee?
Why, Linda?
All right, Emily can be Linda. Do you want to be Lee? Well, because we have Lee's idea and Linda's idea, right?
Wait, who's Linda? Oh, it's this guy.
Lee kept asking. So the Sutton family took a trip to the mountains in the Rocky Mountain National Park. Linda and her brother Lee kept asking,
Are we there yet?
Are you going to participate or not?
Wow.
Yeah. So at one point, their mother answered. Anyone want to do the mom?
Me, no.
Isa, give the answer.
No, but I can tell you that No, but what I can tell you is that we have driven 100 miles and we are about 2/5 of the way there. Wow.
So Linda turned to Lee and asked,
How long is this trip anyway?
so they each started thinking about whether they could determine the length of the trip. From the information they were given, Linda drew this, Lee drew this.
Or what is
I'm not that
what is
good.
Lee even thinking? Linda is so much better.
Yeah,
Wow.
it's not pretty.
Okay,
I'm hardly biased.
so are we ready to talk about this together, or do you need more time?
I got it.
I got Linda's, but I did not.
Oh my god.
Okay, well, we'll analyze both of these, right? So a lot of us are saying, I got Linda's.
I got Linda.
By the way, if anyone saw the mannequin that was brought in 8th grade and was like missing an arm for most of the week, that was Linda. By the way, just that.
Who's Linda?
There's this whole Chloe and like a couple of those, middle schoolers are weird. I don't know how they acquired a mannequin, but they have like from like a store where you would like see in the window like the mannequin. They brought in a mannequin like a couple weeks ago. That mannequin's name is Linda. Just funny. Okay, back here. So Lucy, which method did you think made more sense, Linda's or Lee's? Lee's? Sure. Do you want to talk through how we might be able to look at Lee's method and figure out what to do?
Basically, he took x times it by 2 and over
So
by
what is X representing here? Since you said they took X.
x is representing a side of a triangle.
Well, but really in the concept of this trip,
Oh, he's that. Mm-hmm.
X is the trip. X is the whole thing. By the way, because I keep forgetting this, I'm leaving it up here in the way. Anyone missing an Izod 1416, which I don't really know what that means, but black Izod sweater.
Who's Isaac?
Obviously,
Well, I don't know what my size is.
Isaac? No.
I don't know what a 14. I know a small, medium, large.
that's obviously my.
No? Okay. Izod sweater. Up here if anyone wants it. Because it doesn't fit me. So, Lucy, if X is the whole trip, why did they multiply by 2/5?
Because when you multiply a fraction, it goes lower.
Yeah, because they're 2/5 of the way. Right? Of tells us to multiply. So, All right, if we want to work our way back to x, do you know what we could do to get back to x?
You would
Divide by.
two.
Instead of multiplying by 2/5, Lucy's saying divide by 2/5, and we will come back to that idea in a minute. That is correct, but I don't like dividing by fractions. It's just kind of tricky. We'll come back to that idea in a minute. Grace, you got any thoughts? Which method do you like?
I like Linda's.
You like Linda's better? Let's talk about Linda's then.
W
What could we do with Linda's?
So we already know that 2/5 is 100, so we can just take more. We can just take the other two pieces and make it 100.
So you're saying do this. Who did this and just did another 100 immediately? By the way, today's the first day of spring. Happy spring. This I bought this shirt a couple weeks ago. But this is me trying to manifest some spring weather into like this is where I would like to be in a hammock by a lake near the mountains. I don't think it's gonna work because there was ice on my car this morning. But okay, so back on topic, Grace.
And then if you want to find 1/5, you just divide 100 by 2 because that's 2/5.
Brilliant. If we divide this, we get that like a fifth is 50.
So then you just put down the last one.
So then this is, and then what do we get in total?
You get 250.
250. Any other ways you looked at either of these, Isaac?
So I didn't look at the charts. I don't know why. I thought they were a different problem. But I just saw 2/5 and 100, so I just divided 100 by 2.
So actually you did what Grace just told us to do. You divided 100 by 2,
Yeah, but it didn't do anything. I just saw that they were.
but that only gets you 50.
Then I added it all up, obviously. But like,
Oh, so then you did kind of do the other chunks and
I
bars.
just did 50 times 5.
So you divided by 2 and then multiplied by 5. That's exactly what we wanted.
The thing is, like, I thought the charts were a different problem, and I thought they weren't relevant to what I was doing.
So what Linda has, guys, is what Linda has written down is 2/5 of the trip is 100. And regardless of if you said divide by 2, then multiply by 5, or divide by 2/5, or multiply by, all of those got the same answer. So guys, again, a lot of right ways to get to Florida. Bianca, I hope you're with me. I see a lot of writing, so I assume you're writing down math, but I just to say, because I can't see what you're doing. That's why I'm just saying, hope you're with me. I can't even see your paper because the bin's in the way. So guys, look on your paper. Look for, screw it. I'm just going to turn this on. I get lost in all of my things. This. I forget if it was Isa or who said I just divided by 2/5. But if you have 2/5 times x, and you want to get rid of 2/5, guys, I would either highlight or box this or make your giant 1. Because any number divided by itself, any number divided by itself is 1. Right? Any number divided by itself is 1. However, how do I do... Now wait, this is asking if we didn't have a calculator. How do we divide by 2/5? All right, so I show you right here. And guys, you might want to like highlight keep, change, flip, or highlight reciprocal. Reciprocal, my little memory trick for that was to, instead of saying reciprocal, we said flip-rocal. So guys, if you want to divide by a fraction, it's easier. It's not that you have to, but it's easier if you apply keep, change, flip. And then what's 5 times 2?
10.
What's 2 times 5? So what would 10 over 10 give you? 1, and that's what you want. So then, wait, crap. What should I do with 100 before trying to do this multiplication? Make it a fraction. How? Put a 1 under it. Or you could say put it over a 1. So what's, guys, you should write this down so you've got this work. What's 100 times 5?
500.
What's 1 times 2? What's 500 over 2? 250, and that is our answer. Now, why do we do that? And just more, let's see if my video gets flagged. Because I'm putting other people's videos in my video.
Welcome to Math Antics. This video is all about
I remember this guy.
In order to understand how dividing fractions works, we first need to learn about reciprocals. A reciprocal is just a fancy math term for what you get when you switch the top and bottom numbers of a fraction. For example, if you have the fraction 1 over 2 and then switch the top and bottom numbers, you'll end up with 2 over 1. 2 over 1 is the reciprocal of 1 over 2, and 1 over 2 is the reciprocal of 2 over 1. And an interesting thing about reciprocals is multiplying a fraction by its own reciprocal will always give you 1. That's because you'll have the same multiplication problem on the top and bottom, so you'll end up with a whole fraction, which is always 1. Okay, that's nice. But what do reciprocals have to do with dividing fractions? Well, reciprocals let us do a really cool trick that makes dividing fractions easy. Whenever you have to divide something by a fraction, you can just multiply it by the reciprocal of that fraction instead, and you'll get the correct answer. And that's great news, because multiplying fractions is so simple. This trick of multiplying by the reciprocal works because fractions are really just mini division problems. So when you multiply something by 1 over 2, it's the same as dividing by 2, since 2 is below the fraction's division line. And dividing by 2 is the same as dividing by 2 over 1, because you can turn any number into a fraction by just writing a 1 as the bottom number, right? But look, reciprocals. That's why multiplying by 1 over 2 is the same as dividing by 2 over 1. And it's true the other way around, too. So really, it's kind of like you never have to divide fractions. You can just rewrite your division problems so that you're multiplying by the reciprocal instead. Then when you multiply, you'll get the answer for the original division problem.
Guys, division is tricky, right? Like, it's tougher than multiplication. So, when possible, we'd rather do multiplication than division. So, Linda here, what she's doing, we could have said, and I forget if in this class we said it, but thank you, Lee. What we could do is divide by 2/5, the opposite of multiplying by 2/5. Or, what could we do instead if we want to make that multiplication instead? Instead of dividing by 2/5, we could multiply by what?
5 over 2.
5 over 2, because we multiply by the reciprocal. And that's what Lee set up here, is just, if I could do, because imagine this is where you started, like at home, and this is Rocky Mountain. Now, I don't know why she made it into a triangle. You don't really need a triangle here, but that's what she means. Maybe this was if we had to take the detour, right? If you had to drive the long way, or if a road was closed or something. Question? Answer?
Yeah. So, if fractions are division problems, then why do we call them fractions?
Fractions are both multiplication and division at the same time, and we're about to analyze exactly what that means. So on your graph paper, I wrote it bigger for our visually impaired people. We have 9 halves of something. Is that more than the thing or less than the thing? More. 9 halves. Guys, if you ordered one pizza, right, how many halves should you get? Yeah, so we're going to solve these, but we're on graph paper.
2.
If you order one pizza, you should get 2 halves, right? Half for me, half for Chelsea. We do this like once every other week, right? But they show up to your house with 9 halves. That would be sweet, right? So what we want is 2 halves. What they brought us is 9 halves. So if I try to write this out, we have 9 halves of something. And Grace, what that's doing? Well, everybody, but Grace asked a really good question. This is multiplying by 9 and dividing by 2 at the same time. Fractions multiply and divide at the same time. Equals 27. So I guess I could up here, and you don't have to draw up the number line, you can if you want. I'm going to go ahead and label that this whole thing, because there are 9 here, because I like prepped this and cut it into just 9. That whole thing's 27. I want you guys to take a moment, try to solve this, figure out what is x, or another way to say that is how much will just 2 halves. If each of these is half, right? We're saying each of these little regions is a half. Then how much is in this? This is what we want to solve for. Right? How much is this? How much is 2 halves or 1? Right? How much is 2 halves or 1? Because we keep reusing broken rulers just as straight edges. Because most of the time we just want straight lines. We don't actually have to measure stuff. I kind of want a bunch of those that don't have any numbers on them to just say, like, look, this is a straight edge. That's it. It's just a straight edge.
Look, make a straight edge.
Bro, that could be actually a really good company.
What? That'd be a really good what? For a second, I thought you said cupcake. Maybe I'm just hungry. Can 9 get back to 2 nicely, or should I take 9 all the way back to 1 and then go up? Yeah, go to 1 probably. So if I have 9 and I want to get back to just 1, well, how do I get from 9 back to 1? Divide by 9. And guys, that is why we're going to put a 9 on bottom here to divide.
We don't need to do that since it's already done.
So do you think I have a plan?
I don't know.
Yes.
Well, I mean, you've known me for 6-7 months at this point. Do you think I normally have a plan with where we're going in class?
Probably.
Have I don't want to say ever, have I often led you astray or taken you down a bad road? No. So can we trust me for the current time? But you just kind of spoke up against what I asked us to do. You said we don't need to do, like, if we trust me, maybe we can just. So, like the why, we just explained, we have 9 regions. We're going to take ourselves back to the 1. Xavier, stop what you're doing. Get up to the desk. We're just going to do normal class because now you're distracting me. It's not an issue till now. It's becoming a whole thing where you have multiple chairs. It's too much now. Okay? Too much now. We're going to divide by 9 to get back to just what is one of those regions. Then, how many of those regions do we want? 2 of them. So then we're going to multiply by 2. Or, hey, look, there's that reciprocal. So we want to divide by 9 and multiply by 2. Now, you could do it in whatever order you want. But what's 27 divided by 9? I think we know that. 3?
Yep.
So that tells me one of these, like this, we chose to divide by 9. We are saying we're going to break this because we had 9 halves. We had 9 halves. when I divide by 9 first, what I just figured out is a half equals 3. Because each of these regions we're saying is a half. So this right here we just figured out is 3. Because we had 9 of them. So to get one of them, we divided by 9. Does that make sense? We had 9, we want 1. To go from 9 back to, because our original problem was you're given 9 halves. That equals 27. So guys, think about this like pizza. I ordered a pizza. I should be getting 2 halves. They show up with 9 halves of pizzas, and that is 27 slices. So I separate out all my halves. So I divide by 9. How many slices are in each half? 3 is what we just figured out. So 3 is half of our pizza. How many slices would there be in our whole pizza? Well, 3 and another 3, so 6 total. Or if you just come down here and look at fraction that we want to get rid of, so multiply by its reciprocal. Guys, what's 27 times 2?
Something with a 4.
54 divided by 9. So if you just want to straight up do the math and not use like the number line, guys, all we really need to do is multiply by the reciprocal. So try B. You could just multiply by the reciprocal if you want. If 2/7 is the fraction we want to get rid of, what is the reciprocal of 2/7? 7 halves. Yeah, there's a better way to say it. So try B. Try B. We don't quite have the work that we should right here because you're not directly paying attention. You're like half paying attention. Okay, that's fine, but I need you to know how to do it without a calculator.
I do.
So show me, like with B, write it down and show me what we do. Yeah, like Isa's doing. Like Mason's getting going. So what we would write down first for B is 12 equals 2/7 x. Do I have more than the whole thing or less than the whole thing? Less, because I only have 2/7. Crap. So if you draw this out, I'm going to ignore these extra spots 8 and 9, right? Because I only care about 2 out of, so I have 2. I want 7. These 2 are how much did they tell me? Are 12. Those 2/7 are 12. Well, I think from there I could figure out what 1/7 is, and then I could figure out 7/7. Give this a shot. I'm going to write out a bunch of extra work that you don't need to write out, and then we'll come back and write out the work that we need to. So if you want to, for a moment, ignore what I do up here. I'm going to clone my sheet or my like page, whatever you want to call this, so that I've got another one to start from. you want to show what you're doing on both sides, either beside it or under it. So you want to see that you're actually doing that times 7 halves to both of these. So you kind of jumped over the step of doing that, which is like, okay, once you get really good at it, but just be careful jumping over steps, right? Because you kind of jumped over showing that. Here you showed it of what's happening, but it doesn't quite reinforce that this is going to cancel, that the reciprocal cancels the original fraction. So that's the only critique that I would have, is like kind of maybe giving a little bit more written out. All right, so what I do first, the kind of unnecessarily long way. If I have 2 of something, I can divide by 2 and find out 1 of them. So 2/7 was 12. What would 1/7 be? 6, right? So if I divide, so I find out that 1/7 is 6. How many sevenths do I need? 7. So I multiply by 7, and now I get, well, what's 6 times 7? 42. What's 7 over 7? Oh, that's just a 1, so I'm done. Or the quicker way to do this is to do what on both sides? Xavier, you want to help me out? What can I do on both sides? I mean, yeah, like, what am I going to, like, give me the numbers, like,
Well,
are you wanting me to actually divide or actually multiply? We might think about division first. Go ahead and keep going. Divide by,
7 over. Wait, what are you talking?
exactly, because I think you missed some of my teaching when you were trying to like figure out how many chairs are necessary for you back there. Lucy, help me out. We can. You guys keep making things harder than they need to be. So, Xavier, if you want to divide, we would be dividing by 2/7. However, that's like, I don't know that I want to say impossible, but that's really hard without a calculator. Instead of dividing by a fraction, here's a tip. Keep, change, flip, and what we actually want to do is times, what do we call it when we flip this? The reciprocal. So 2 times 7 will give me 2 times 7 will give 14. What's 7 times 2? So we'll get 14/14, which is good. But if we did it over here, we got to also do it over here. No, crap. What should I do with 12 before I start? Put it over a 1 to make it a fraction. So now we show that times 7 over 2. This got 14/14, which we know is going to cancel. Or reduce out. I should say reduce out. What's 7 times 12? 84. Over 2 times 1? 2. What's 84 divided by 2? 42. So we get 1x is 42. Questions. We used the reciprocal multiplication. See.
How can you do like the extra stuff? Well, I don't get what you did.
Say more. What about it don't you get?
At like, how come you didn't just like make it like keep change flip?
We did.
Like when you like added like.
We skipped over the keep change flip to get to the point of after the flip. This is after the change and the flip. The change changes to multiplication. The flip flips the fraction from 2/7 to 7/2. This is after keep change flip happened. Let's do one more and see if that helps solidify. Negative 3/4 x. Negative 3/4 x. Negative 3/4 x equals 21. I'm going to go ahead and put 21 over 1 since we keep doing that anyways. Now, if you really want to look at what's happening here, we want 4/4. They give us 3/4. well, negative, but that is kind of, we'll deal with that in a minute. So they tell us, okay, this 3/4 is 21. Hey guys, we'll get back to the negative in a minute. Just look up here real quick to see like that this makes sense. If 3/4, I'm ignoring the negative for now. If 3/4 is 21, could we figure out each of these what's 21 divided by 3? 7. So each of these, and guys, that is when we do divided by 3, divided by 3, right? We're dividing by 3. That's why it goes under the division line of the fraction. That makes us divide by 3. Now, how many of those 7s will we need to get the whole thing? How many? 4. Because we need 4/4. So we need to now multiply by 4, multiply by 4. However, in this situation, we can't just ignore the negative. We got to take it with us. It just makes our math tougher because we got to make sure we pay attention to something's got to become negative. So we divided by 3 and multiplied by 4, or what you could say is we took this, flipped it over, reciprocal on both sides. So what's 4 times negative 3? Negative 12. What's negative 3 times 4? And what's a number over itself? That is why we did what we did. Reciprocal multiplication wipes everything out to a 1. Then I got to do the math on this side, because this is a bit tougher math. 21 times 4. 84, yeah, 84. 1 times negative 3. Negative 3. What's a positive divided by a negative going to give us? A negative. So we're going to get x equal to negative, what's 84 divided by 3? 20. It's less than 30. 28. Yeah, I think that sounds good.
No, it's 28. How come?
Yeah, go ahead.
So how come you how come you did how come you did the times 3 on both sides?
I did not times 3 on both sides. I times by 4. I divided by 3. If I write this out long form, I'm going to clone this and I'm going to write it out long form. I don't know what I just did. Yeah, this is what I want. All right, let's clone this. So I'm going to erase all of this. I'm going to go step by step. Guys, if you feel comfortable with this and you want to go ahead and work on your homework, you are more than welcome to do that. I'm going to literally not use the negative this time. So I'm going to get rid of this and I'm just going to act like the problem doesn't have a negative. Okay? I don't know. I mean, they're releasing early. We still got time. So I guess Mr. Combs just doesn't care about K or S. If you have, K or S means what time is it? If you have 3/4 of something is 21. 3 of the 4 is 21. So how can I get to 4/4? Well, I need to figure out what this little section is. And that little section is a 4th. Just listen for a second. So if I have 3/4 and I want 1/4, I could on both sides, I could divide by 3. 3/4 divided by 3 will give you 1/4. So we can do, just broke my marker, 1/4 of the thing we're looking for. What's 21 divided by 3? 7. Yeah, we figured that out last time. So then if I have every 1/4 is 7, now I need to multiply by 4 to figure out that 4/4 is 28, and this together, this and this, to multiply by 4 and divide by 3, that's where we start, like, that's why we use reciprocals, because we want to divide by 3 and multiply by 4. This lets us do it in one step. I mean, I wrote it out as 2 separate steps, but if I go back here, this is why we did that. Get rid of the 3 on top, so we put a 3 on bottom. Get rid of the 4 on bottom, so we put a 4 on top. They will reduce out. That is all the time we got. Do your practice. Come see me if you struggle. Thank you very much. Test on Thursday. Pay attention to what's due on Friday. Get your work done. I did, Sammy. Good catch. I said what?